Hello everyone and welcome to STEM School. Now in today's video I'll be explaining what exactly is the Pythagoras Theorem, and as soon as I've covered the basics I'll quickly move on to some typical challenging exam questions you tend to see so that you're best prepared for the exam. So before I begin, please do hit that like button and consider subscribing to the channel for similar tutorials just like this. Okay, let's get started. So Pythagoras Theorem is a very well known concept. Whenever you have a right angle triangle and you know two lengths of the triangle, then you can use the Pythagoras formula to find the third length of the triangle. But it is important you remember that it has to be a right angle triangle. So that is what we have here. We have a right angle triangle. Now the formula is a squared plus b squared is equal to c squared, which tells us how to find the hypotenuse of the triangle, okay? So the hypotenuse is the longest side, okay? So you'll know the hypotenuse because it's just opposite the right angle symbol. So it's hypotenuse, okay? So that's the longest side of the triangle, opposite the right angle, okay? The formula here is obviously a squared plus b squared is equal to c squared. It's a simple formula. What you have to know is how to label each side a, b and c, alright? So what you should know is the hypotenuse is opposite the right angle, it's the longest side, so that is length C. And then the other sides can be labelled A and B, just like that. It doesn't really matter what sides are A and B as long as you understand that the length C is the longest side of the triangle. Okay, so this is a very simple concept to understand. So what we'll do is we'll jump into some examples, okay? So what we have here is a right angle triangle. We have length 4, length 6, and then we want to find the hypotenuse, the longest side, okay? So when you see this example, when you see a right angle triangle, you should think Pythagoras immediately. So what you do is you write the formula down. C squared is equal to a squared plus b squared, okay? Now for clarity, I recommend that you always label each side. So the longest side, that will be C, and then the other two sides will be A and B, just like that. So that's what you do, just substitute these values in. So we have c squared is 4 squared plus 6 squared. And then what we can do is take the square root of that. So it'll be square root of 4 squared plus 6 squared. And when you pop that into a calculator, you get c is equal to 7.21. Okay? So you can double check your answer because the longest side should obviously have the largest number. So 7.21 is larger than 4 and 6. So you know you're on the right lines, just like that. Okay? So very simple. Let's move on to the second example. So we have a right angle triangle. We've been told two lengths. We have to find the third side. So immediately think Pythagoras. So let's do that. So it'll be c squared is equal to a squared plus b squared. And then of course just label it. So the longest side will be c, okay? And then we can label the other sides a and b, just like that. Right, so let's do that. So we actually know the hypotenuse this time. So you just make sure you substitute the numbers correctly. So C is 10, then A we don't know, and then B is 7 squared, right? So what you have to do in this case is just rearrange the equation. It's very simple, right? So it'll be 10 squared take away 7 squared is equal to A squared, okay? So the unknown is A. What we do is we take the square root of it. So we have A is 10 squared take away 7 squared. Just like that, and then when you pop that into a calculator, it'll be A is equal to 7.14, okay? So you can double check this number. It should be smaller than the longest side, okay? So 7.14 is smaller than the longest side, which is 10, alright? So that's when you know you're on the right lines. But yes, it's a very simple process to follow. It's a squared plus b squared is equal to c squared. And that's a magic formula to remember. You just need to get comfortable with labeling the sides. The hypotenuse is the longest side, which is opposite the right angle. And you need to get comfortable with labeling A, B and C correctly, okay? But what we'll do is we'll move on to more challenging examples that you more typically see in National 5 and GCSE exams, alright? Alright, so we'll have a go at this first exam question then. And you know, when you look at this question, this is quite typically asked. They'll have some sort of circle diagram and they'll mix in Pythagoras with it. But it doesn't look like we have to use Pythagoras at all here. But when you actually analyse the question further, you'll see where you can use Pythagoras, right? What they'll tend to do is give you a circle and they'll tell you the radius. And because they tell you the radius, you can make some sort of triangle on the diagram, okay? So let's have a look at this question. It's saying that the shape below is part of a circle, centre 0. So the circle has radius 13 centimeters and AB is a chord of length 20 centimeters, and we have to calculate the width of the shape, right? So what you have to do is make use of the fact that they've told us the radius is 13 centimeters. We want to find the width, okay? So the fact that they've told us the radius is 13 centimeters means that I know that from this point here to the origin is 13 centimeters, and I then need to find this length here, okay? And what I'm going to do is call that length x from the origin to the end here of the midpoint of the chord. So what we can actually say is that the width, right, the width is equal to 13 centimeters plus x centimeters. Okay, so that's the formula that we will have to sub into at the very end. We need to find what x is. Okay, so what we can do further is then annotate the diagram. Okay, so make use of the fact that the radius is 13 centimeters. So I know from the origin to point A is 13 centimeters. I know that the point from the origin to B is also 13 centimeters. Okay, so you can see the shapes forming here. Okay, so I know that this is a chord. Okay, so this is in the center. So what I know is that from point B to the midpoint, or A to the midpoint, is also going to be half of 20 centimeters. So it'll be 10 centimeters from here to here. Okay, so what I'll do is I'll draw that diagram out. So what we have is this point here is the origin. Then we have this line here is 13 centimeters. And then we have this line here, which is half of the chord, which is 10. Okay, and then we need to find x, right? So x is this horizontal line, just like that. And of course it is a right angle triangle. Okay, so we've figured that bit out. So what we can do is use Pythagoras to find length x. So what we do is we write c squared is equal to a squared plus b squared. Okay, so c squared is 13. So 13 squared is equal to, so we can do 10 squared plus x squared, right? And then what we can do is just rearrange this equation to find x. So it'll be 13 squared take away 10 squared is equal to x squared. Alright, then just take the square root of that. So it'll be x is equal to 13 squared take away 10 squared. Okay, and then since this is a calculator paper, we just pop that in. So root 13 squared take away 10 squared is x is equal to 8.31 centimeters. Okay, doke. Now what we do is we substitute that into the width calculation. Okay, so we found what x is. So width is equal to 13 centimeters plus 8.31 centimeters, which we calculated as x. So we know that the width is going to be 21.31 centimeters. Okay, so that's us figured that out. So yeah, just to summarize, what you have to do is just look at the diagram and make use of the fact that they told you the radius is 13 centimeters, and then just draw lines, and then eventually you'll see shapes forming, and then you can make triangles from that. Okay, and just remember that the chord, you can obviously half the length of the chord just to make the right angle triangle. Okay, so that's a general idea how to approach these types of questions. Alright, so we'll have a go at this exam question then. And immediately when you look at this diagram, it doesn't shout to you that you need to use Pythagoras at all, but it becomes more apparent when you actually analyse this problem in more detail. So let's have a look at this. So we were told that Chris wants to store his umbrella in a locker. The locker is a cuboid with internal dimensions 40 by 40 by 70 centimeter height, okay? So the umbrella is 85 centimeter long, and he thinks it will fit into the locker from corner P to corner M. Is he correct? And we have to justify our answer. So essentially what we have here, we have an umbrella 85 centimeters long. This guy thinks he can put the umbrella in this box at an angle from P to M. So essentially what we want to do is make sure the length from point P to point M is longer than 85 centimeters, because that means the umbrella will be able to fit. Okay, so what we'll do is we'll just draw on this diagram. So we'll draw a line from point P to point M. This is the length that we want to check. Okay, so when we look at this diagram, what we can actually start to do is split this into a triangle somehow and make use of the dimensions given to us, okay? Because we have a slope, okay? So that kind of makes us think of the slope of a triangle. So that's what should be going through your head. So what we can do is draw a line from point P down here, okay, and then draw a line from here to point M, just like that. And what happens when you do that is you have a right angled triangle, just like that. So what I'll do is I'll draw this to the side so you can see this more clearly. What we have here is a triangle just like that, okay. So we have point P here, then we have the right angle symbol, then we have point M, and then we have the red line that I drew here from point P to point M. This is the length that we want to figure out, so I'll put that as X, okay? So if we look at the diagram, what numbers can we sub into this? So I know the height is 70, right? So I can put from here, point P to the bottom is 70, okay? Now, do I know this length here? I don't, okay? There's no information given to that tells us that. So we need to find this length here, okay? So what I can do actually is focus on this box, okay? So focus on this box. We have a 40 by 40 box, and what I'll do is I'll draw this to the side here. So we have a box, 40 by 40, and then what I'll do is I'll draw the blue line just to make it clear what we're finding. We're trying to find this length of the blue line. What I'll do is I'll call it C, okay? So we have a box, 40 by 40 by 40, and then 40 here. And of course you'll have a right angled triangle when you split it up in the diagonal. So if I find length C here, that means I've found this length here. Then I know two sides, that means I can find the hypotenuse here, X, okay? So we need to do Pythagoras twice. So let's first of all find C. We have C squared is equal to A squared plus B squared. So we have C squared is equal to 40 squared plus 40 squared. And then you can take the square root of that, so it'll be square root of 40 squared plus 40 squared. And then when you pop that into the calculator, what do you have? You have 56.57 centimeters, okay? So just be careful you remember the units on the end. So there we have, we've actually found this question mark length here. We found 56.57, okay? So what I can do is just rub that out, and then I'm going to write 56.57 centimeters here. And now we can do Pythagoras again to find what length X is. Okay, so let's do that. So what we have is, what I'll do is I'll just stick to what you know. So I'll have C squared is equal to A squared plus B squared. Okay, so C is X. Okay, so it'll be C squared is equal to 70 squared plus 56.57 squared. And then what you do is you take the square root of all of that, so it'll be 70 squared plus 56.57 squared. And then when you put that into the calculator, you get C is equal to 90 centimeters, which is what we labelled as length from P to M is equal to 90 centimeters. Okay? Okay, so we need to finish the question. We need to add in a conclusion, right? So since length PM is equal to 90 centimeters, which is greater than his umbrella as 85 centimeters, then umbrella will fit. Then umbrella will fit. Okay, dope. So it's just a little bit of problem solving. This is a common question where you have to kind of split like a cuboid and you can make triangles out of it. It's just a bit of problem solving. Just make use of whatever lengths that they give you into the question, okay? But it's best just to draw the diagrams out clearly so then you can make out what you need to figure out for the next part of the question. And now we're going to have a go at this question here, and I wanted to show this question because sometimes exams will kind of mix algebra with Pythagoras, alright? So sometimes the sides of the triangle, it won't just be numbers, you'll see, you know, X and Y and things like that, okay? So we just need to get used to this, alright? So let's have a look at this question. We've got a triangle with X, 7X and 10Y. And then we've been told that all dimensions are in centimetres. We have to use Pythagoras theorem to work out the exact value of x over y, alright? So we have to find this fraction x over y. So it actually tells us we need to use Pythagoras theorem, but either way, if I saw this triangle in the exam paper, it's a right angle triangle, and what immediately I would think of is, do I need to use Pythagoras, do I need to use trigonometry, alright? That's the kind of thoughts that will go in my head. So let's have a go at this. We have to use Pythagoras theorem, so let's just have a go at writing Pythagoras theorem. We have c squared is equal to a squared plus b squared. what we can do is label A, B, and C quickly. So the side opposite the right angle will always be C, and then we can have A and B, just like that. What we have to do is just sub it in. Okay, so we have 10y, and then be careful, you're going to put the square on the outside of the brackets, alright? Then we have x squared plus 7x, then all squared. Okay, so just be careful with the squaring. So what's 10y squared? That will come down to 100y squared, and then we have x squared plus 7x squared is 49x squared. Now we can add both of these two terms together. We have an x squared here and a 49x squared here. So we have 100y squared is equal to 50x squared. So we've defined x over y. So it's easier just to write 50x squared on the left hand side. We're normally used to dealing with that. So 100y squared there. So what we have to do is just make a fraction up. So what we can do is we can write x squared all over y squared will be equal to 100 over 50. Okay, so you can just split it up like that, right? Now, if you remember this rule, right, say if we had a over b, right, a squared all over b squared, that's the same as writing a over b and put big brackets over the fraction right squared. Okay, so we can use this rule. This is a rule of indices, a rule of powers, right? So what we can do is to x over y, and then we put brackets over the fraction, then square, just like that. Okay, that makes it easier to then take the square root of the other side. Okay, so you just need to remember that rule. So what does that leave us with? We have x over y is equal to 100 all over 50, and then I'm going to take the square root. Okay, so this is a calculator paper, so we can just put that in the calculator, and what do we get? So x over y is simply root 2 as the final answer. Okay, so yeah, you just need to get used to using Pythagoras, mixing with some algebra, but as long as you remember the famous rule, a squared plus b squared is equal to c squared, you'll be absolutely fine, okay? So the last type of question you could get asked is something called the converse of Pythagoras. Essentially, this is just about proving whether a triangle is right-angled or not. So what tends to happen is that you get given a triangle and you're already told the lengths of the three sides of the triangle, and what you have to do is substitute those three numbers into the Pythagoras formula to see if the right hand side is equal to the left hand side. So in other words, if a squared plus b squared is equal to c squared, then it is a right angled triangle. So that is the concept to remember for the converse of Pythagoras, alright? So what we'll do is we'll have this, got this question here, this exam question, and then we can see how to apply the converse of Pythagoras to test if a triangle is right angled or not. So the diagram on the right here shows the position of three towns. So Low Town is due west of Midtown, so Low West is here, is due west of Midtown, and the distance from Low Town to Midtown is 75 kilometers. Midtown to Hightown is 110 kilometers, that's the hypotenuse, right? And Hightown to Lowtown is 85 kilometers, which is that, right? And we've been asked, is Hightown directly north of Lowtown? And we have to justify our answer. So when I look at this question, what I see is I see a triangle, and we've been given three sides of the triangle, okay? So that immediately implies I should use the converse of Pythagoras. So what that means is we are testing whether this right angle is whether this triangle is indeed right angled or not, okay? So what we can say is that if Hightown, HT for Hightown, if Hightown is directly north of Lowtown, then this triangle has to be right angled. Okay, so it's best for these types of questions just to, add a sentence just to show the examiner what you're thinking, alright? Because we need to justify our answer, we need to write a few sentences, right? So if Hightown is directly north of Lowtown, then this triangle has to be right angled, okay? So what we have to do is simply just write the Pythagoras formula, a squared plus b squared is equal to c squared, alright? And then we just substitute the numbers in. So this first of all label, so the hypotenuse is 110 kilometers, we can label that C, and then we can label this side A and then B, okay? So what we can do is just substitute that in. We have 85 squared plus 75 squared is equal to 110 squared. So all we have to do is make sure the left hand side is equal to the right hand side. Now this is a calculator paper, so we can just substitute those numbers in. So what do we get? We have 12,850, and then we have 12,100 as 110 squared. So as you can see, the left hand side does not equal the right hand side. So what we do is we put a score through the equal sign to show that they're not equal to each other. And then what does that mean? Okay, so you just had a sentence, right? So 12850 is not equal to 12100. This triangle is not right angled. So Hightown, HT, is not directly north of Lowtown. Okay, because the left hand side does not equal the right hand side, then we don't have a right angled triangle. If these two numbers were the same, then the triangle will be right angled. So that's how we use the converse of Pythagoras. Just substitute the three numbers into Pythagoras, just see if the left hand side is equal to the right hand side. Alright folks, so that's everything that you need to know about the Pythagoras theorem. So if this video has helped you, please do remember to hit the like button and consider subscribing to the channel. And then of course join me in my next video where we'll be looking at the trigonometry of right angled triangles. So I'll see you guys then.